book of AI governance. And his work has been published in the in prestigious journals like the American Economic Review, the Review of Economic Studies, the Journal of Econometrics, the Journal of Monetary Economics, the Journal of International Economics, and the Journal of Public Economics. His work has been cited in Bloomberg, in The Economist magazine, and in the Wall Street Journal. And he has won several fellowships and awards for his work, including from the Institute for New Economic Thinking, the Effective Altruism Long-Term Future Fund, and the Hewlett Foundation. So Anton Kornick studied economics, maths, and law at the University of Vienna and worked for several years in IT and finance. And he earned his PhD in economics from Columbia University. And he has held various positions at the University of Maryland and Johns Hopkins University. And he has been a visiting scholar at Harvard University, the Bank for International Settlements, the International Monetary Fund, the World Bank, as well as several central banks, where he has given lectures and courses. So with that, let me welcome Anton. A very warm welcome to you, Anton, and we're very much looking forward to your talk.
Thank you very much, Sanket. Sanket and I had the pleasure of both doing our PhD at Columbia University, so we have known each other for a very long time, and I'm honored to be back and give a seminar at your university, Sanket. So I should tell you a little bit about what motivated this work. Last fall, when I first saw the powerful capabilities of the latest generation of language models, it really made me rethink what my work as an economist should focus on. I had been following the progress in artificial intelligence since about 2015 as kind of my main research focus. And my feeling in fall 2022 was that things have suddenly accelerated and have proceeded much faster than what I expected. And my contacts in the leading AI labs were starting to show me demonstrations of these large language models. And it really made me kind of reevaluate what to focus on. And in some sense, this paper is the output of this reevaluation process. And in it, I try to wrap my head around what the emergence of these large language models and their powerful capabilities of cognitive automation implies for economic research. So I want to start by giving a little bit of a broader introduction into how to think about these new generation of AI systems. We know that there was a really significant breakthrough in deep learning that kind of led to significant progress in AI in the 2010s. But by now, that's the old paradigm of AI. The advances in deep learning created a lot of value, but there was always still this category difference between human and artificial intelligence. Now, in the 2020s, we have a new paradigm, the paradigm of foundation models, which are the models that underlie generative AI systems, such as ChatGPT or other large language models. Now, this new paradigm, of course, builds on the deep learning paradigm, but it feels qualitatively different. As all of you who have played with these language models probably have noticed, they suddenly feel eerily human-like. They are not quite at a human level of intelligence, of course, but their capabilities are becoming increasingly similar to what human capabilities are. One of the distinguishing characteristics of these foundation models is that they are powered by really large neural networks that are in the order of magnitude of 10 to the power of 12 parameters and growing. And I should emphasize that is in the ballpark of the number of 10 to the power of 12 is actually above the number of neurons that we have in our brain. And since the architecture of the brain and of these deep neural networks is slightly different, you can't really compare it one for one. But in any case, their complexity is kind of similar magnitude as the complexity of our brains. So maybe it's not surprising that they are so eerily human-like. And yeah, the leading category of these foundation models are, of course, these large language models like ChatGPT. So what is powering this rapid progress? All of you have probably heard about Moore's Law, which was a regularity that one of the co-founders of Intel originally identified, and that has, for some almost miraculous reason, been holding for the past half century at least, and that predicts that the computing capacity of chips is, and I simplify a little bit, roughly doubling every 2 years. So as economists and finance professionals, we all know the power of exponential growth. If something doubles every 2 years, it quadruples every 4 years, it grows by a factor of 1,000 every 20 years. But that's not all. If you look at the amount of computing power that has gone into the leading AI systems, that has actually been doubling every 6 months for the past decade. So just to make this tangible, if it doubles every 6 months, it quadruples every year, it goes up by a factor of 1,000 every 5 years. And that's what has been happening with these cutting edge systems. And that's what underlies the rapid progress that we have seen in foundation models and also large language models. So how do these systems work and how should we think about them? Many of you have probably heard that they are trained via this process called self-supervised learning. They are fed essentially all the body of text, of somewhat decent quality text that's available on the entire internet. And during this self-training process, the system is fed the beginning of a text and then the next word is blinded out. And it has to guess what's the next word, or technically speaking, the next token, which encodes the syllables of words. And it is trained on predicting that as best as possible on terabytes of data. And when the first version of these types of language models, something like GPT-1 in 2018, was trained, people were suddenly surprised that based on being trained to predict the next word, the system could actually write somewhat coherent sentences. Nowadays, we are at the stage where they can already write coherent paragraphs, coherent essays. This is something that people really did not expect, because if you're just trained to predict the next syllable in something, who would have guessed that these systems can suddenly write coherent essays, right? So I think the best way of thinking about this, of thinking about what's happening, is that these systems develop what I want to call a world model during the training process. And that world model can be applied to a wide range of tasks. That world model is what's behind when we ask ChatGPT a question that requires an intelligent answer. The ChatGPT responds based on its model of the world. And yeah, in some sense, this really forces us to reevaluate our understanding of what human brains do. Two things I want to notice is first, the developers of large language models have identified regularities that they call scaling laws. And these scaling laws kind of capture how the advances in large language models are kind of predictable. So they can make pretty decent predictions if we double the amount of parameters of these systems, or if we double the amount of training compute, the training computing power, or if we double the amount of text that we feed into the training process, we know how much more powerful, how much better at predicting the text that is a reasonable response to our questions the system are going to be. But in addition to these predictable advances, the language models regularly display new emergent capabilities, capabilities that surprise their creators and that suddenly arise. I guess the best description is based on the ever more fine-grained nature of the world model that the systems are developing. So here are a couple of examples of these emergent capabilities. What happens is on the horizontal axis of these graphs, you see the amount of training compute, so the amount of floating point operations that goes into training these systems. And then the lines that you can see are different large language models trained by different companies like Google, OpenAI, DeepMind, and so on. And what you see is once the amount of training compute surpasses a certain threshold, all these systems suddenly develop the capability here in panel A to perform certain arithmetic operations. So they have been taught to predict language, but they can suddenly do arithmetic. They can transliterate, they can unscramble words, they can engage in Q&A, and all these are capabilities that suddenly emerge once you throw enough computing power at the systems. And it's kind of like an S-curve, it emerges and then it converges towards 100. So I want to make two warnings. The first one, it is easy and also dangerous to overestimate the capabilities of these large language models. The second one, it's also easy and dangerous to underestimate their capabilities. I think the best way to understand it is their capability surface is very different from our human intelligence. They can do things that are very hard for us. They can't do things that are very simple for us. And so that makes it difficult to relate, and it makes it difficult for somebody who wants to argue, oh, these are just stochastic parrots, to put them down, or for somebody who wants to hype them to say, oh, this is human-like artificial intelligence. I think at this point, it's not yet. The important thing to remember is their primary objective is to generate text, and everything else, being truthful, being appropriate, and so on, are secondary side constraints. One quick quote, and I have to be quick going over a few slides. The CEO of Coursera said in January, anybody who doesn't use these systems will shortly be at a severe disadvantage. So he's capturing this notion that these tools really enhance our cognitive ability, our productivity, and we better use them. I will present kind of three main theses about how these large language models will affect our research in economics and finance. So first, my first thesis is large language models will play an increasingly important role in cognitive automation. So the automation of any kind of knowledge task, including the automation of research. And in the next few years, large language models will make researchers significantly more productive. So right now we are at the stage where they are most useful for automating certain microtasks. The transaction costs are really small, so it's easy throughout the day to use these large language models to do little pieces of your work much faster than you would regularly do them. But soon they will be able to perform more and more research tasks. And actually, when I first wrote this paper, only GPT 3.5, that we know as ChatGPT, was publicly accessible. By now, GPT-4 is also available. So what I will do in the second half of my presentation, I will give you some demonstrations from GPT 3.5, and I will note what the differences are in GPT-4. For GPT-4, you need to pay a subscription, so it's not available to anybody. Another point, something that I think we economists are very well aware of since the days of David Ricardo, it's a good idea to focus on our comparative advantage. So content generation will be more and more devalued, but the act of discriminating what is good content and what is bad content is something that we humans still have an edge on. And of course, we can also organize projects and so on and engage in higher level planning tasks that are at this point still a little bit more difficult for language models. So what I want to do next is I want to walk you essentially through a roadmap of different capabilities of large language models for economists. I have split those capabilities into 6 categories: ideation, so the process of coming up with good ideas; writing, background research; coding, data analysis; and finally math. I also want to emphasize the limitations of these models, though. They are primarily language models by their name. They are not quite as solid on analytic concepts yet. They learn from the training data. They do not remember stuff across sessions. The training data cuts off in the past for both GPT 3.5 and GPT 4, that is 2021. And I think that's in part for safety reasons. It makes it harder, for example, to come up with misinformation that's relevant for the politics of the day. And the amount of text that you can put into these systems is still limited. But all these limitations are constantly being pushed out. And I could see that so vividly when I wrote the paper, and a month later, GPT-4 was out, and all the numbers I had on this slide were no longer relevant. Another point I should emphasize is the performance and the capabilities of the systems depend a lot on good prompt engineering. So prompt engineering is like a mix of programming and using natural language. In fact, it is programming in natural language, you could say. And one way of thinking about it, with GPT-3, where we know the exact numbers, every request that you put into the system is converted into a vector of size 1500, into a 1500 dimensional mathematical object. And if you give a very short prompt, you are wasting most of the dimensions of that vector. But if you give a very specific prompt, sometimes it's really useful to give follow-up requests in ChatGPT, for example. Then you're taking maximum advantage of all 1500 dimensions, and you're shifting the model into the state from which you want it to respond. So let me jump over this. These are the 25 capabilities that I explore in the paper, and they are grouped into these six categories. So let's start with ideation. Language models are extremely useful for brainstorming, for providing counter-arguments, even for evaluating ideas. When I mark something with green, as you see here to the left of brainstorming and counter-arguments, it means it's a powerful capability that regularly provides useful output. If it's yellow, I would say sometimes it gives you useful responses, sometimes not so much. And then if it's orange, then I would say it's currently a bit more experimental. And as I said, the coding that I'm reporting here is based on GPT 3.5. So let's show an example. I entered into GPT 3.5, please brainstorm economic channels through which advances in AI may increase inequality. Came up with 10 different channels, automation of low-skilled jobs leading to job displacement, and so on and so forth. I won't read all of them. I will tell you that it listed all the channels that I could brainstorm within 5 minutes, and it did so in 20 seconds. And yeah, towards the end, it gets a little bit repetitive. It's kind of like if you force somebody in an oral exam to say more and they don't really know what to say anymore. Providing counter arguments. So here I entered my hypothesis is that AI will increase inequality. What are the main counter arguments? And it gives a list of 8 pretty solid counter arguments, I would say. Evaluating ideas. I'm writing a paper on the effects of AI on inequality. Admittedly, this is kind of a dumb question, but I thought I'll just see what happens. What do you think is more useful? A paper on how AI increases inequality or a paper on how AI reduces inequality? The system says that depends on the purpose. I will paraphrase. If you are looking for a positive description of mechanisms, then it is more useful to focus on how it increases inequality. If you want to write a normative paper, it's better to focus on how AI can reduce inequality. I thought that was actually a pretty good insight. Next category of capabilities, writing. So this is kind of the bread and butter of language models and something that I perhaps use it the most for. The first example is synthesizing text. The way my brain works is I find it relatively easy to brainstorm bullet points, and then the system can convert it into fluent and well-formulated paragraphs. So for example, here I'm writing, please write a paragraph that integrates the following arguments, include a topic sentence, and then I give it a few ideas. I sometimes tell it in parentheses, add examples, offer solutions. And it wrote a very well-written paragraph that basically narrates all of this. It saves me a couple minutes. Evaluating text. What are the main stylistic shortcomings of the following text? And I copy-pasted an old version of the abstract of the paper. And then you can see here in green, the main stylistic shortcomings are that it is overly wordy and lacks a clear structure. The sentences are too long and complex, making it difficult to follow the argument. Additionally, the text does not provide any concrete examples so you can see it's quite harsh in a way. I will say, admittedly, every single point is actually correct. Part of it is that when we write an abstract, we kind of try to condense as much as possible into it. So it's the nature of abstracts, but part of it is that I could write it better, and I try to improve it a little bit. So the current abstract takes into account a little bit of the feedback that I got from ChatGPT. Editing text. Here I entered a sentence in which I included a whole bunch of grammatical mistakes. These in plural, right? Describe in without an S at the end, 6 domain without an S at the end, and you can see the spelling mistake. The system corrected every single one of the mistakes, and then I asked it, can you explain the corrections? And it explains the main corrections and why it did so. This is particularly relevant for people who write text that's not in their native language, right? Here I ask it, can you rewrite the following abstract to make it comprehensible for 8th graders? It can do that too. It can convert things to kind of simplify it. You can make it for 4th graders too. Sometimes I also find it useful for, here I wrote, please suggest 2 or 3 catchy titles for a paper with the following abstract. And I entered the abstract of one of my papers. And it came out with pretty good examples. The paper was already published at the time, so I did not use it. But whenever I start a project, I use this brainstorming function now. And oftentimes I kind of combine multiple things with my own thoughts to come up with the title. It just helps to get the creative juices flowing. All right, background research. Here I have focused on a bunch of tasks that we researchers face every day, starting with researching the literature. I'm sure many of you have heard about the tendency of language models to hallucinate. And that means it's actually not, so large language models are not a good resource for searching for references. I will say, though, that GPT-4 is a category better than GPT 3.5. But there's another tool, elicit.org, that I am demonstrating here, where you can enter a plain language question and it comes up with answers. So this is partly self-promotion. I asked, what is the impact of AI on inequality? And one of the first papers it came up with is one that I've written on AI and its implications for income distribution and unemployment. It can summarize text, and it's actually really good at that. So it can, let's say you want a quick summary of a paper, you can copy paste stuff. You have to be aware there is a limitation of how much text you can paste. So oftentimes you will only be able to put in the introduction and conclusions, but it provides really good summaries. Can also translate text. So this was from an experiment when I gave a similar presentation at the Bank of Finland, and it translated the abstract of my model into Finnish. And the native speakers on the call said that this was really a stellar translation, better than what Google Translate would provide. It can explain economic concepts, and this is now something where the language models are moving from being a research assistant to really being a tutor. And in fact, this is something that my students first told me about it. Language models can explain general concepts in most cases really well. So I tried out a whole bunch of other examples, and I found that it provided really lucid answers, and it really serves as an excellent tutor. However, then one of the questions I answered when I was really impressed, I asked it, what is the second theorem of welfare economics, which is very important for us as economists, right? And it instead answered the first welfare theorem. So at first, I had already received like 10 different really good explanations of concepts. At first, I doubted myself, am I confusing the welfare theorems now? And just to be sure, I quickly Googled it. But no, the system just got it plain wrong here. And it insisted that the second theorem is the first and the first is the second. And I tried to prompt it again and again. And even when I said it's the other way around, it insisted that the first was the second. So it was incorrigible. Well, I tried the same thing again with GPT-4, and the answer was flawless. But yeah, you still have to be somewhat skeptical, especially with the older generations of models. All right. So this was about background research. Now, the next set of capabilities that is really useful is coding. In some sense, one of the reasons why the leading AI labs really care about this is because it helps them to write code faster and to make progress to the next generation of the model faster. And that's part of the reason why we have seen this really accelerating progress over the past year. Right now, the labs are already using GPT-4 to write, I guess, GPT-6, because GPT-5 is already in training, and so on and so forth. And it is becoming really powerful. So again, this is a demonstration of GPT 3.5. GPT-4 is a lot better. This is all available via OpenAI as Codex, but also via Microsoft GitHub as Copilot. The code that works best is Python and R, but it can do stuff in many other languages. So this is an example, write Python code to calculate the Fibonacci numbers, and just goes, I mean, this is a relatively simple request, right? But it demonstrates it can do the required recursions. It can translate code really efficiently. So here I'm asking it to convert from Python into MATLAB. It does that flawlessly. Can also debug code. Sorry, this is the wrong picture here, but I introduced a mistake and asked it to find the mistake, and it had no problem with that. It is not always the case, though, I should say. So sometimes it has difficulty with that. And also with coding, if you ask it for more complex tasks, for example, I asked it to solve the Ayagari model. It got about the first 2/3 correct. And then there is an outer loop that you have to run in order to determine the steady state level of capital and the interest rate. And it couldn't do the outer loop. So it saved me perhaps 80% of the time that it would take from writing it from scratch, but it couldn't do everything. All right, we also do a lot of data analysis in economics, and this is where language models offer new capabilities. They can score things. So here, for example, I gave it 10 tasks from ONET, which is a database by the US Bureau of Labor Statistics that provides job descriptions. And I asked, classify each of these tasks into easy to automate or hard to automate. This is kind of like, there was a recent paper by OpenAI researchers and somebody from the University of Pennsylvania, GPTs as GPTs, they did this systematically to predict what tasks in the economy will be automatable by GPT. And yeah, it lists the tasks. It tells me hard to automate for the first one, and then the explanation is requires human judgment and decision making. And it gave a pretty reasonable answer for all of them. Now, the last category I want to cover is math. GPT 3.5 displayed the beginnings of some really useful capabilities, but overall made regular mistakes and wasn't that great, frankly. So I'll show you an example. I wrote the text in white here. Utility is, and I gave it a quasi-linear utility function. So X enters in an isoelastic fashion and Y enters linearly. And then I tell it the prices of the goods are P and 1. And I enter a consumer and I press generate. And I was kind of impressed that it wrote the whole optimization problem. Well, this is LaTeX code. So let me show you what it looks like if I compile that. At first, I was really impressed. Then I looked at it in detail. Can you see where I'm hovering my mouse? I'm hovering over the derivative of the Lagrangian with respect to X. And what you can see here is the system made a mistake that I guess is very common to us from correcting undergraduate problem sets. When it took the derivative of this isoelastic function, it kept the 1 minus rho in the denominator, even though that should have canceled out, right? And then based on that mistake, it derived everything else correct. But yes, there was a mistake. So what I did next is I corrected the mistake by hand. I entered all the text that is in bold, and then asked it to solve for X and Y, and then let it continue the derivation based on the corrected equation, and then it got everything right. So yeah, maybe it actually saved time because I didn't have to enter all the LaTeX stuff, but you have to watch it carefully in math. Now, when I tried the same problem with GPT-4, it got the answer correct. So you can see that there's been really a significant advance in mathematical capabilities. So this kind of concludes my demonstration of the capabilities of these models. And I want to end in the last part of my presentation by talking about the broader lessons that I think we can draw. So in the short term, as we could see in these illustrations, large language models are both useful assistants, but also tutors already. They allow us to automate many micro tasks that we engage in on a daily basis and to deliver significant productivity gains. And yeah, as I said, we have to focus on our comparative advantage. We'll also have to change our workflows. We let the systems generate content, and we discriminate content. What's the medium-term outlook? This is a little bit more speculative now, and it is essentially based on me having followed the evolution of these language models for the past 5 years. I think, and that's probably the broad majority opinion, they will become better and better assistants and tutors. But what I think I also want to emphasize, as these large language models become better, the role of humans in many cognitive tasks will diminish, will increasingly turn into rubber stampers of what these systems produce. And eventually, our large language models assistants may graduate and become researchers of their own. So I would not be surprised if at some point these language models evolve to the point that I can tell them, write a paper on X, and they can write a better paper than any Harvard or MIT or Chicago economist. So based on that, I think that in the long term, the most insightful economic research will be created by large language models without any human help. And as an analogy, I want to resort to basically a quote by Garry Kasparov from a book in which he kind of attempted to process his defeat to Deep Blue in the 1990s. And in the conclusion of that book, he wrote thousands of years of status quo human dominance, a few decades of weak competition, a few years of struggle for supremacy, then game over. For the rest of human history, machines will be better than humans at chess. Eventually, and again, speculative, but I can see some writings on the wall. The same may be true for economics and many other cognitive tasks, right? The competition period is a tiny dot on the historical timeline. So right now we are in this competition period. These models are really powerful at some of the cognitive work we are doing, but we clearly still have the edge in other things. And then Kasparov observes the competition dot gets all the attention because we feel it intensely when it occurs during our lifetimes. But it's almost always better to start looking for alternatives and how to advance the change into something better instead of trying to fight it and hold on to the dying status quo. So let me maybe, since we are talking kind of about the bigger picture now, I thought I will put in one slide here that compares these foundation models to our human brains. And from the perspective of information theory, computers and brains are both devices that process information, right? They take inputs and they compute outputs. So from that perspective, brains are computers. Well, how do they differ? For brains, they're large, deep neural networks with about 100 billion neurons, 10 to the power 15 synapses. Well, all those of us who are parents know that raising a brain takes a lot of time and effort, and then it can be fine-tuned to excel in specific applications. For example, we can go to graduate school in economics. And then these brains display emergent properties. They can suddenly come up with new things that they weren't trained on. But they're also opaque and difficult to interpret. Well, let's look at foundation models. Right now, I guess GPT-3 had 10 to the power 11 parameters. They didn't release the number of parameters for GPT-4 publicly, but estimates are that they are more than 10 to the power 12. The pre-training takes a lot of time and effort, many months, tens of thousands of GPUs. And then after the pre-training, these systems can also be fine-tuned to excel in specific applications. And they also display merchant properties. They're also opaque, difficult to interpret. So you see, there is a lot of parallels between the two. In the long term, the computer scientist Richard Sutton kind of described a bitter lesson for how progress in AI occurred. He observed that in the old days, AI researchers tried to make their systems smarter by programming very specific knowledge into them. So, for example, when IBM created the chess computer that defeated Garry Kasparov, they spent tens of millions of dollars, hired lots and lots of grandmasters to teach the system how to best play chess. And that helps in the short term, but the benefits eventually plateau. And in the long term, brute scaling, meaning just throwing more computational power at the problem, has always proven more successful. So in chess specifically, when DeepMind created the chess computer AlphaZero, that did not rely on any human knowledge. It learned everything from scratch, and it beat all humans and all existing chess computers that were trained with human inputs after just about a day of training. Now, this same bitter lesson that in the long term, brute scaling of computational capacity will prove more successful, that will probably apply to economics as well. So Wittgenstein said, the limits of my language are the limits of my world. This is kind of interesting when applied to language models. And soon these language models will expand the limits of our world. But in the meantime, so this is probably on the horizon, and we don't want to discount it. We don't know the timelines, and reasonable people disagree greatly on how long this may take. But in the meantime, there are lots of really interesting and urgent economic questions that we need to solve. What will the new era of cognitive automation imply for labor markets, for education, for technological progress, for growth, for social welfare? And I guess the positive note I want to end on is, as of right now, our human brains are still the best technology around to answer these urgent questions. Thank you.
Thank you, Anton, for a fascinating presentation on a topic that literally everyone in the world is now thinking about. So we have a few questions from the audience, but before that, I would like to ask maybe one or two. So when you're thinking about these disruptive impacts in terms of economic research, but more broadly in terms of jobs, so there's a lot of concern that the AI can actually disrupt quite a number of jobs, and particularly India is. I mean, countries like India have a lot of commoditized IT services, information technology services. And there's a concern that many of these services, let's say legal services, accounting services, many of these backend services might actually get, because of AI, many of these jobs might disappear. So there's a lot of concern in the IT industry in India. And there is also a lot of concern among in the financial sector as well, that many of the finance jobs might actually get disrupted. So, I mean, this is a little broader than simply economic research, but and I was struck by your statement that it's dangerous to underestimate the capability of AI, and it's also dangerous to overestimate the capabilities. And so we are now in a situation where we don't know enough about whether, I mean, in what direction AI might go in terms of whether it will be a sort of, I mean, most of the examples that you've given are in terms of helping researchers. But you also made a statement that at some point, your research assistant can become a colleague in terms of doing the research, right? So, so I'd like to hear your thoughts on that.
Yeah, so at present, there are more research assistants and tutors. And I don't know if it will be GPT-5 or GPT-6 or maybe 7, but I do anticipate that eventually there will be large language models that can do research at human levels and perhaps eventually beyond. Now, going back to the first part of your question, I think the fears that you describe are absolutely justified. Once a task has been outsourced, that means it has been kind of well-defined and packaged in a way that you can ship it across the ocean and ship the result back. And having that sort of process also makes it easier to automate it subsequently. And when OpenAI announced GPT-4, it simultaneously announced that it is working on partnerships with a law startup, I think it's called Harvey, it's a partnership with a big US investment bank, on partnerships with essentially companies across many sectors of the economy that are working on automating tasks like what you described using GPT-4. And yeah, what I've demonstrated to you was only GPT 3.5, and GPT-4 is even better. So these language models, they are already very powerful. I expect that within the next half year or so, we will see them deployed in lots of different areas of the economy. This deployment, it always takes some time because organizations don't move at the same speed as OpenAI in most cases. But it will likely happen. So even if we just roll out the current technologies without any further progress, this is going to be really disruptive. But at the same time, and I showed this slide with the doubling every 6 months, right? We are at the same time making this really rapid progress, and we will have a new system come out within, I expect, the next year or so, that will be more powerful than GPT-4, and that will be able to do even more tasks.
So thank you. So I just have one follow-up question on AI and inequality. I mean, you have done quite a lot of research on this particular topic in terms of the impact of AI on labor markets and inequality. So do you think that, I mean, there has been a lot of concerns about these superstar firms, and that there's a lot of increasing concentration across different sectors, different industrial sectors, and you have a talent being rewarded in an outsized manner. So will these LLMs actually, or not only LLM, but will AI actually accelerate that trend?
Yeah, that's a really interesting question, and I'm of two minds. I guess in economics that's acceptable to say. So there's one force that is very much nivelating, which is if these systems can really perform any kind of cognitive capabilities, then all those of us who now think they have an edge because they have more education or they are specialists in certain cognitive things, will no longer have that. And ultimately, I think it will be a very deflating experience for a lot of people who kind of define their identity around their cognitive capabilities. And that means that at some point, our cognitive capabilities will all be worth the same, which means not very much. Now, in the meantime, while we are on the road to reach that point, I think there are some forces towards that nivelation. So, for example, let's say, some medical experts, like radiologists, they may see their cognitive skills really devalued. And that reduces inequality, right? Because right now they're very highly paid. And I think the same will be true for a growing number of professions, eventually for academics as well. Because yeah, a lot of what we do is simply text, right? There will also be superstar forces, I think. For example, if you have one set of people who become very adept at using these tools, they will be more productive and their wages will go up. Those people who, let's say, are not literate enough to use large language models, they may be left behind. So that's kind of a more short to medium term phenomenon. There are also some preliminary results that show that language models can, for example, complement the skills of call service center agents and help particularly the worst performing ones to reach somewhat better performance. So that would also be an equalizing force. I think we really have to see how these forces are going to play out.
Thank you. It will be very interesting times ahead. We have a couple of questions from the audience. So Anton, are you able to see the Q&A?
Yes, I see 9 open questions. Oh, so many.
I think maybe you can take a few of them, maybe not all of them. I mean, you don't have to answer everything, but maybe there's one from Rahul Rao. And there's also one, maybe you can start off with that.
Let me try to give my best understanding on this question about a universal logic. So the interesting thing about language models is they very much follow the connectionist approach, which is everything is kind of a messy neural network. The language models, they are not very good with logic. They're not very good with math. They can write beautiful sentences, but they still suck at math. And in some ways, that's really a huge contrast to, let's say, the old AI of the 1900s, the second half of the 20th century, the good old-fashioned AI, when we thought we can approach a lot of AI problems with a logical approach. And this is a connectionist approach, which is a different philosophy, almost, I want to say. It's you just throw lots and lots of computational power on the problem. You have a system with hundreds of billions, trillions of neurons. Nobody understands why, but somehow the system spits out something useful. It's really opaque, kind of like our brains. I think we showed examples, speaking to the second question, who can exceed use the equations. I'm not sure. Oh, thank you.
You can skip some of the questions.
Can quantum computers play a better role where AI lacks? So I have to admit, I'm not an expert in what specific capabilities quantum computers would add. But some of my friends who are tell me that they would probably not lead to a breakthrough in AI. They can help accelerate some of the training processes a little bit, but yeah, honestly, this is secondhand knowledge. Are there any regulatory efforts to govern large language models? I think, and I just saw a news report on that in the US today, I think people are really starting to have this conversation. There is this age-old question that the Luddites already debated, right? Should we hold back advances to protect labor, or should we not? There is an even more significant question. I'm sure many of you have heard about the concerns that superhuman intelligences may actually pose existential risks on humanity. So maybe that would also be a really good reason to think about how to carefully govern these systems. Will the time come when large language models write something truly insightful? I have no doubt that that time will come. The only question is when exactly. So I know that a lot of AI researchers kind of predicted, oh, we will reach human level AI systems in the 2040s. But then over the past 12 months, a lot of people have revised their timelines that it may actually happen a lot faster. And, you know, some experts say it may even happen within the current decade. I have a very diffuse prior on these questions. I don't know. Elon Musk says it will be 2029. What will be the impact on research funding? Shouldn't it be logical to fund language model to do better and faster economic research? At some level, yeah, that would make a lot of sense. So right now, what the AI labs are doing is they are pouring a lot of resources into making their systems better programmers, because that kind of leads to a self-reinforcing explosion in their capabilities. And so Demis Hassabis, for example, the co-founder of DeepMind, he said, our goal is to solve intelligence and then use intelligence to solve everything else. And economics would, I guess, be part of everything else. And yeah, I think, so one of the underlying questions that I see in a lot of the points here is, are these systems truly creative, right? And I think the point where it became clear that they are truly creative is when AlphaGo beat the world's leading Go player and displayed strategies and moves that we humans at first didn't even understand. So it came up with entirely new strategies for playing Go. And now if we look at all the generative AI, I think it's very hard to deny that they are creative. And, you know, the best way for understanding what these models do, I think is not, as some people describe it, as averaging out the knowledge that's out on the internet, but a better description is they create world models of their own. So they have a model of how the world functions. And that model of how the world functions is becoming more and more abstract. And ultimately, creativity is to combine concepts from our knowledge about the world in novel ways. And the more ability to abstract you have, the more creative these combinations look to us. So I have little doubt that they are already creative and that they are becoming more creative. And yeah, right now in economic research, I think we humans still are more creative. Some job roles which won't get affected by AI. So let me go back to my brain and computer analogy. I do believe that any kind of cognitive capabilities that the human brain can perform may also be replicable by machines. And the question is, what will be able to be replicated, how soon? And I don't have a good answer to that. I think we are also on the brink of seeing really rapid advances in robotics that are driven by these same language models hooked up to physical devices. So over the next year or two, I expect that we'll see a lot of breakthroughs in robotics. How long, Sanket, you tell me if we are too much beyond time and we have to cut off.
I think, yeah, we're just above 1 hour. So I think we can maybe wrap up in the next 2-3 minutes.
Okay, if a country like India, where labor is cheap, how long will it take for AI to become an economic choice? Is another question. So I think right now AI is already an economic choice for lots of tasks that are performed, for example, by call centers, and it's just a question of rolling it out. And in your research, in my research, there are lots of tasks where AI is very much competitive. The marginal cost of using these systems is so low that as soon as they can do something, humans are almost by definition no longer competitive. Then there is a question that emphasizes that our human brain is a sensory perceptive device. Yeah, so I very much agree. And as I said, I think we are in the process of having labs that are hooking up these models to robots. And that is also leading to breakthroughs in robotics. And the last question I see here is there a paper you have already written where AI helped you do something creative? Is picking a title creative? If so, then yes, definitely. I have used it for, I would say at this point, there are small creative inputs into my papers, nothing path-breaking yet. And that reflects the stage of these models. But these kind of small creative inputs, they are getting more creative over time. And eventually, I think they will display really this kind of significant creativity that we researchers exhibit as well. Thank you.
Thank you so much, Anton. I think this was a fascinating and really insightful presentation on a topic which is extremely relevant. I mean, this is something that we will see how things play out, and and there would be tremendous impacts on all aspects of human activity. So I would like to thank Professor Anton Korenek, and we also invite you to visit IIM Ahmedabad if you ever plan to come to India. And so we look forward to seeing you in person. Thank you very much.
Thank you, and have a good evening.
Thank you very much, and have a great day. Thank you.
Bye.
We can end the webinar now.